Hi class, and welcome to the first video of our probability course. Today we're going to talk about the basic principles of counting, the first being the multiplication rule. So if we have to make two choices, and the first choice has n options, and the second has m options, the multiplication rule says that the total number of choices we have is n times n. So we just multiply the number of options we have for each choice, and that gives us the total choices. For example, suppose we're at a restaurant and we're ordering an Italian soda, which is one of my favorite drinks. And the drink options are the following. We can choose a small, medium, or large, and they have the flavors cherry, raspberry, lemon, and strawberry. How many different drinks could we order? Well, the first choice is size, and we have 3 options. The second choice is flavor, and we have 4 options. So by the multiplication rule, we know that the total number of choices we have is 3 times 4, which equals 12. For example, a small cherry soda, or a small lemon soda, or a medium cherry soda, or a medium raspberry, and so on. This is actually a small enough number that if you'd like, you could write out all the pairs and find out that there are, in fact, a total of 12 different sodas that we could order. There's no reason to limit ourselves to 2 options, or to 2 choices, however. We could actually go up to k choices. So suppose we have n1 options for the first choice, and n2 options for our second choice, and n3 options for our third choice, and so on until we get to the kth and last choice, and we have nk options. The generalized multiplication rule says that what we should do is multiply all the options together. So the options we have for all the choices are n1 times n2 times n3, and so on down to nk. Another notation for that is this capital pi sub I equals 1 to k of n sub I. I'm sure you've seen a sum before with the capital sigma for sum and pi for product. So the pi, when you see that, means to multiply over all the indices I equals 1 to k. So now that we have our Italian soda ordered, we want to order dinner. We're going to choose an appetizer from nachos, fried mushrooms, and potato wedges, an entree from spaghetti, steak, and chicken, and a dessert from ice cream and apple pie. So how many different dinners could we come up with? Well, first we can choose an appetizer, and there are 3 options. The second choice has 3 options for entrees, and we get to choose one of 2 desserts. The generalized multiplication rule tells us that the total number of dinners we could create is 3 times 3 times 2, which equals 18. Again, this is a small enough number. If you wanted, you could go through all the different options. We could choose fried mushrooms with spaghetti and ice cream, or we could choose potatoes with steak and apple pie, for example. And if you write down all the different combinations to make a dinner, you're going to find that there are 18 total. Now let's look at a slightly different scenario. So there's a child stacking blocks numbered 1 through 4. We want to count how many ways can the child stack the blocks. For example, they could stack the blocks in order 1, 2, 3, 4, but they might stack the blocks in any order. For example, they could choose 2, 4, 1, 3. So let's go through the second example more closely and see how many choices we have for each option. Well, for the first block, there are 4 options. 1, 2, 3, or 4. We could put any block at the base. And in our second example, the child chose block number 2. So whenever we go to stack the second block, we only have 3 options left. 1, 3, and 4, because 2 is taken. And in the second example, the child chose block number 4. And that leaves 2 options for the third block, 1 and 3. The child chose to stack block 1, and then for the fourth block, there's 1 choice. You're just left with block number 3 to stick on top. That's your top block. So it's different from the previous example of choosing dinner, because whenever you ordered dinner, you could choose any appetizer, say the fried mushrooms, and that had no effect on your desserts. You still had apple pie and ice cream to choose for your desserts. However, if the child chooses to start with block number 2, in this example, then that does affect the second block. You can no longer choose block 2. Whereas in the first example, the child started with block 1, and then in the second, you could choose block 2. However, the number of options at each step don't change, and so we can still use the generalized multiplication rule. The total number of choices we have is 4 times 3 times 2 times 1. We multiply the number of options at each step. And 4 times 3 times 2 times 1 is 24, so there's 24 ways to stack the blocks. So when we're talking about ordering or rearranging a set of objects, like the blocks, those are called permutations. So we're permutating the blocks. And when we find an answer of the form 1 times 2 times 3 times 4, that's called 4 factorial. And in general, n factorial is 1 times 2 times 3 times 4 times 5, and so on until you get to n. So you keep multiplying until you get to n, and then that's where you stop. And the number of ways to permute n objects, or to rearrange them, is n factorial. And that's not meant to be an exciting statement necessarily. That exclamation point at the end is the factorial that's in the definition just above it. So the number of ways to rearrange 4 blocks is 4 factorial, or 1 times 2 times 3 times 4 equals 24 ways. Now let's say that we come across these 5 people trying to form a committee: Alice, Bob, Carl, Dana, and Earl, which we will call A, B, C, D, and E for short. They need a committee of 3 people. How many ways could they choose their committee? For example, Alice, Bob, and Carl could be on the committee and not Dana and Earl. Or they could decide that Bob, Dana, and Earl should be on the committee but not Carl or Alice. So what we're going to do is permute them by choosing an order for the best committee members from best to worst, all 5 members. And the number of ways to permute the 5 members, A, B, C, D, and E, is 5 factorial, which is 1 times 2 times 3 times 4 times 5, or 120. However, we have some redundancy, because choosing Alice, Bob, Carl, and not Dana and Earl is the same as choosing Bob, Alice, and Carl, and not Earl and Dana. The redundancy for those on the committee, since there are 3 of them, is the number of ways to permute those names. So that's 3 factorial, which equals 6 permutations. Oh, that's supposed to say choice 1, not of chosen 1. And for those not on the committee, it's 2 factorial, which is 2, or 1 times 2, of those not chosen. So the total, then, is 5 factorial divided by 3 factorial times 2 factorial. So whenever we multiply the 1 times 2 times 3 times 4 times 5, there's redundancy that we need to cancel, so we divide. And we divide by the redundancy in each of the groups, which gives us an answer of 120 divided by 6 times 2, which equals 10. So the 3 can form 10 different committees. So from a set of size n, the number of ways to split into 2 groups, one of size k and one of n minus k, is n factorial divided by k factorial times n minus k factorial. The numerator, n factorial, refers to the number of permutations of the entire set. The k factorial is the number of permutations in the group that was chosen, and the n minus k factorial is the number of permutations of the group that was left. And so we divide by those to cancel out the redundancy and forming the same groups. And there's also a shorthand notation for this. So that's read as n choose k. It's an n over a k, but without a line between them. So that's not a fraction. It's just an n floating over a k with parentheses around it. And when you see that, read that n choose k, and if you want to evaluate it and figure out what it's equal to, it equals n factorial divided by k factorial times n minus k factorial. That's all there is for this video, so I'll see you next time.